Let's look at the math problems in Chapter 1. There are two types of problems: base conversion between different numerical systems, addition and multiplication for a given base. Type 1, base conversion. From the textbook, we know that these bases had been used. You can find out which people used which system. The decimal system, base 10, is the system we're still using now. The binary system, base 2, is used in computer science. The decimal system uses 10-digit symbols, and we are familiar with these symbols. The binary system only uses 2 digits, 0 and 1, and the duodecimal system will need 12 digits, because we only have 10 digits for decimal system, so we use T to represent 10 and E to represent 11. We use the subscript M to distinguish between numbers to different bases. So this number is to base 4 and this number is to base 12. When no subscript is written, it will be understood that the number is expressed to the base 10. In the positional numeral system, different numbers in different positions represent different meanings. So this example, 312, from right to left, the first digit 2 represents 2 ones. The second digit 1 represents 110, and the third digit represents 3 hundreds. So from right to left, those digits represent 1, 10, 10 squared, 10 cubed, 10 to the fourth, and so on. Similarly, this number to base B, from right to left, 2 represents 2 ones, 1 represents 1b, and the third digit 3 represents 3b squared. So from right to left, a number in base B those digits represent 1, b, b squared, b cubed, and so on. Type 1, convert a number from a given base to base 10. So this is an example from textbook on page 25. Express 3012 to base 4 in base 10. From last slide, we can see from right to left, these symbols represent 1, 4, 4 squared, 4 cubed. So 3 times 4 cubed plus 0 times 4 squared plus 1 times 4 plus 2 times 1. We add them together. 198 will be the equivalent number in base 10. Second example, and this number is expressed in base 12, and we want to convert this number to base 10. So because this is in base 12, so from right to left, each digit represents 1, 12, 12 squared, and 12 cubed. So we have 3 12 cubed, and so 3 times 12 cubed plus t, which is 10 in the duodecimal system, times 12 squared plus 1 times 12, and plus e, which is 11 in a duodecimal system, times 1. And this gives us the answer. So let's summarize how to convert a number from a given base to the ordinary base 10. So if we have a number expressed in base b, to convert it to base 10, we multiply each digit with what it represents. b, 1b, b squared, b cubed, and add them together. That would be the equivalent base 10 number. The reverse problem, we want to convert a base 10 number to a given base. For example, express 198 in base 4. So we have to reverse what we did before. We may assume 198 has 4 digits, A, B, C, D. And A represents 4 cubed, and B represents 4 squared, and C represents 4, and D represents 1. We notice 4 cubed, 4 squared, and 4, they are multiples of 4. So we divide the equation by 4, both sides. And 4 cubed becomes 4 squared, 4 squared becomes 4, and 4 divided by 4 is 1, and 1 times C would be C. And D times 1 is D, divided by 4 is D over 4. Because in the base 4 system, each digit is less than 4, because we only have 0, 1, 2, 3 in the base 4 system. So this makes D over 4 a fraction. And let's look at the left side. 198 divided by 4. The quotient is 49, and the remainder is 2. So 198 divided by 4 can be written as 49 plus 2 over 4. And look at this equation. The left side has an integer 49, and the right side, because this is identity, so the integer on the left should be equal to the integer on the right, and the fraction on the left should be equal to the fraction on the right. So we have 49 equals A times B, 4 squared, plus B times 4 plus C. And the fraction 2 over 4 on the left equals D over 4 on the right. And this fractional equation gives us D equal to 2. And this is the last digit. And let's see how we found this digit. So we divide 198, the number given, by 4, and the remainder 2 is the last digit. Similarly, we can find out the other 3 digits, C, B, A. So let's look at this integral equation. Notice 4 squared and 4, they are also multiples of 4, so we may divide by 4 again. So step 2, we look at this integral equation and divide by 4 both sides. So 4 squared divided by 4 is 4, 4 divided by 4 is just 1, 1 times B is B, C divided by 4 is C over 4, which is a fraction, and 49 divided by 4, quotient is 12, remainder is 1, so 49 divided by 4 is 12 plus 1 over 4. And the integer on the left, 12, corresponds to the integer on the right, A times 4 plus B. And the fraction on the left, 1 over 4, equals the fraction on the right, C over 4. So we have C equal to 1. And similarly, the integral equation will help us to find our B. So in next step, step 3, divide by 4 both sides again. 12 divided by 4 is 3, and the quotient is 3 and remainder is 0. And 4 divided by 4 is 1, b divided by 4 is b over 4. So the integer on the left 3 equals the integer on the right a, and the fraction on the left 0 equals the fraction on the right b over 4. So we have b equals 0 and a equals 3. And if we look at this integral equation, divide by 4 both sides again, the remainder will be 0 and the quotient will be the remainder will be 3 and the quotient will be 0. So we can consider 3 as the remainder of 3 divided by 4, which gives us the last digit from right to left. So from these 3 steps, we found out A, B, C, D. And so we found our base 4 number, 3012. So basically, to convert a number in base 10 to a base 4, we divide the number 198 by 4 repeatedly to get our digits from right to left. So here is the process. 198, the number given in base 10, divided by 4. The quotient is 49, the remainder is 2, which is the first digit from right to left. And 49, the quotient divided by 4, the new quotient will be 12 and remainder will be 1, which is the next digit. And 12 divided by 4 again, the quotient is 3, remainder is 0. 0 is the third digit. And 3 divided by 4, the quotient is 0 and remainder is 3, which is the fourth digit. So from bottom to top, these are the digits of the number in base 4. And when we reach 0, the quotient, we can stop this process. Here are some examples of exercises. And 17, we can use the process we had before. Divide by 4, the remainder is 1, quotient is 4. So we put 1 in last position, and we use the quotient 4 divided by 4 again, and the remainder will be 0, and we write down 0, and the quotient is 1, and we use 1 to divide by 4 again, the remainder will be 1, and the quotient is 0, so we can stop. But notice these numbers are relatively small numbers, so we may have another way to do the problems. It's not necessary to use the process we had before. Just think about the meaning of base 4 numbers. The numbers in base 4, from right to left, the digits represent 1, 4, 4 squared, 4 cubed, and so on. So the number 4 here, which means 1, 4. So we can put 1 in the position which represents 4. So 1, 4 plus 0 will be 4. Similarly for 5, because 5 is 1, 4 plus 1, so we put a 1 in the position of 4, 4, and put another 1 in the position of 1. So together will be 5. And the same for 6. 6 is 1, 4 plus 2. 7 is 1, 4 plus 3. And 8 will be 2 4s, so we put 2 in the position of 4, and 9 will be 2 4s and plus 1, and 10 will be 2 4s of plus 2, and 11 will be 2 4s plus 3, and 12 is 3 4s, so we put a 3 in the position of 4. 13 is 3 4s plus 1, and 14 3 4s plus 2, 15 3 4s plus 3. 16 will be 4 squared, so we put a 1 in the position of 4 squared. 17 is 4 squared plus 1, so we put 1 in the position of 4 squared and another 1. So we can see if we have small numbers, we can just think about how to write this number as 4 squared plus 4, how many 4 squared plus how many 4s and plus how many 1s. But for the large numbers, it's difficult to imagine these numbers, so we might need to use the process we had before. Type 2. Addition and multiplication for given base. We're familiar with the addition and multiplication tables for base 10. So let's see how to figure out addition and multiplication for base 4. Because 0 plus any number will be the number, so the first row, 0 plus 0 is 0, 0 plus 1 is 1, 0 plus 2 is 2, 0 plus 3 is 3. And similarly for the second column, 0 plus 0, 0 plus 1, 0 plus 2, 0 plus 3. And if we look at 1, 1 plus 1 is 2, 1 plus 2 is 3. And so far everything is similar to base 10. But 1 plus 3 is 4, and in base 4, 4 is 1 0. So we convert the base 10 number 4 to a base 4 number 1 0. And similarly, we find out the third column. 1 plus 1 is 2, 1 plus 2 is 3, and 1 plus 3 is 4, which corresponds to 1 0 in base 4. And we can find out 2 plus 2 is 4, so it is 1 0, and 2 plus 5 is 3 is 5, it is 1 1. And the same for the fourth column. And the last column, 3 plus 3 is 6, which is 1 4 and a 2. And now let's look at a multiplication table for base 4. We know 0 times any number is 0, so the first row we have 0 times 0, 0 times 1, 0 times 2, 0 times 3 will always be 0. And the same for the second column. And if we look at the third row, 1 times 1 is 1, 1 times 2 is 2, and 1 times 3 is 3. The same for the third column. And the fourth row, 2 times 2 is 4, and we know in base 4, 4 should be 1 0. And 2 times 3 is 6, which corresponds to 1 2. And 3 times 2 is 6, so it's also 1 2. 3 times 3 is 9, which is 2 4s plus 1. Okay, so we're ready to use these tables to do addition and multiplication in base 4. So these two numbers are expressed in base 4. And we carry out the addition like we did for base 10 numbers. So 2 plus 4, if we look at the table, 2 plus 3. 2 plus 3 is 1 1. So we write down the 1 here, and we carry the other 1. 1 plus 3 plus 3 is 5. So it is 1 1 in base 10. So we write down the 1 and carry the other one, plus 2 would be 3, and carry down this 3. And then let's look at an example of multiplication. This example is on page 27 in the textbook. So we start with the last digit 3. 3 times 2 from the table is 1, 2. So we write down 2 and carry the 1 here. And 3 times 1 is 3, plus the 1 we carry will make a 4, which is 1, 0. So we write down 0 and carry 1. 3 times 0 is 0, plus the 1 we carry is 1. And 3 times 3, check the table, is 2, 1. So we write down 2, 1. And then we look at the next digit 3. Because it's the same as the first row, so we put down the numbers 2, 1, 1, 0, 2. And the last digit 2. 2 times 2 from the table is 1, 0. So we write down 0 and I carry this one. 2 times 1 is 2, plus the 1 we carry will be 3. And 2 times 0 is 0. 2 times 6 from the table, it is 1, 2. So we write down 1, 2. Now we add these three numbers together. 2 carry down, 0 plus 2 is 2. 1 plus 0 plus 0 is 1. And 1 plus 1 plus 3 is 5, which is 1, 1. So we write down 1 and carry the 1. Plus 1 plus 2 will be 4. And 4 is corresponding to 1, 0 in base 4. So we write down the 0 and carry the 1. Plus 2 and plus the 1 we carry, which is 5. And it should be expressed as 1, 1 in base 4. So we write down the 1 and carry the other one. 1 plus 1 is 2. And that's how we do addition multiplication for numbers in base 4. The process would be similar for addition multiplications of numbers in base 10, except we have to be careful to convert our sum or product to base 4 numbers.